So we have to remember that the energy of a photon is proportional to its frequency. So E equals Planck's constant times the frequency. Planck's constant is equal to 6.63 times 10 to the negative 34 joules times seconds. So to calculate the frequency of a photon, we just do the energy of that photon divided by Planck's constant. So for problem A, we have 17 kilojoules. So if you remember from problem 1, we have to do dimensional analysis to keep everything in joules. So 1 kilojoule equals 10 to the 3 joules. 1 kilojoule equals 1,000 joules. So this gives us 17 times 10 to the 3 joules. So to do the first problem, we just do, to calculate the frequency, we can just do E, which is 17 times 10 to the 3 joules divided by Planck's constant, 6.63 times 10 to the negative 34 joules second. So the joules can be crossed out. And then using a calculator, we're left with 2.6 times 10 to the negative, to the 37, sorry, not negative, to the 37th power, 1 over seconds. So 1 over seconds is the equivalent of hertz. So this means that the answer is 2.6 times 10 to the 37 hertz. So let's do the next problem. The next problem is we have 564. E minus 25 is the same thing as times 10 to the minus 25 joules. Now we don't have to convert the units because the units are already correct here. So all we have to do is use our equation, which is the frequency is equal to the energy of the photon divided by Planck's constant. So the energy is 564 times 10 to the negative 25 joules divided by Planck's constant, which is 6. So memorize this constant because it's useful. You don't have to always look for it. Times 10 to the minus 34 joules times seconds. So the joules can be crossed out. And then we're left with 8, using our calculators, 0.51 times 10 to the 10. Because 1 over seconds is the same thing as hertz, we usually just write hertz for frequency. On the calculator, we'll see E10. So E10 is just the same as times 10 to the 10. So for problem C, we have 98 picojoules. So picojoules is using dimensional analysis because we got to convert it to joules. 1 picojoule is equal to 10 to the minus 12 joules. This means that we have 98 times 10 to the negative 12 joules. So now we can just use our equation. Frequency equals energy divided by Planck's constant. So the energy is 98 times 10 to the negative 12 joules divided by 6.63 times 10 to the minus 34 joules times second. So the joules cross out, and then we are left with, using our calculators, 1.5 times 10 to the 23 1 over seconds, and so the 1 over seconds is the same thing as hertz. Okay, so that's our answer. Let's go on to the next one. So for the last one, we have 230 joules. So this is in the correct units, so we don't have to do dimensional analysis. So we just plug it back into our equation. So frequency equals the energy of the photon divided by Planck's constant. So we have 230 joules divided by 6.63 times 10 to the minus 34 joules times second. The joules cross out, and we are left with, using our calculators, 3.5 times 10 to the 35th hertz. So again, remember, 1 over second is the same as hertz. And often, so I'll just right here, hertz equals 1 over seconds, or often see it as s to the minus 1. So let's move on to problem number 3.